So today we're going to talk about forming covalent compounds. In my last video we talked about how you form an ionic compound, and covalent compounds are very different from an ionic compound. The first big difference is an ionic compound is the complete transfer of an electron, but in a covalent compound it's the sharing of an electron. With a covalent molecule, it's two nonmetals, which is different than an ionic compound, which is a metal and a nonmetal. So we don't really care about the charges when we're talking about covalent molecules because the charges don't matter. What we will talk about are what are called valence electrons. And you should have learned before this what a valence electron is. A valence electron are the electrons that are in the outermost shell of a molecule. So let me show you how I know my valence electrons. So first let's do charge. So the charge is going across, and they will always be this way. So the first one is like lithium. Lithium, and this whole column is going to be a positive one. The column with beryllium, the whole column will be a positive 2. We're going to skip over our transition metals because we don't really care about them yet. We will later, but not right now. The next one is the row with boron. But I'm only going to talk about aluminum when I'm talking about the charges, and it's a 3 positive. Boron is it's a thing all on its own, so we'll talk about boron in a little while, but not right now. Carbon doesn't participate in a ionic bond. It only participates in covalent bonds, so we don't really care about its charge. What we will say is that we'll have 4 valence electrons, but we'll get there in a second. Nitrogen, the row with nitrogen, the whole entire column has a 3 minus charge. The row with oxygen has a 2 minus. The row with fluorine has a 1 minus, and the row with the column with neon doesn't have a charge. Those are our inert gases, right? Inert, they do not react. They will if we force them to, but we don't really want that, so they're not going to react naturally. Then we have valence, and valence is very different from charge. Valence is the number of electrons, again, in the outermost shell. So valence electrons going from left to right, ignoring transition metals, we don't care about them, they don't matter, goes 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's what we care about. So when we're doing covalent bonds, we're going to count our valence electrons. When we do Lewis structures, this is what we're going to do. So let's do some practice examples. The first one, so carbon has 4 valence electrons, so it's going to be 4. And then oxygen has 6, but there's 2 of them, right? So 6 times 2, 12, plus 4 is 16. So that's good. The next one's CF4. Carbon again has 4. Fluorine has 7 valence electrons, and there's 4 of them. So it's going to be 32. Put a little plus sign. This next one is acetic acid, and we're going to talk about acetic acid actually in the next few weeks, so that's a good thing to know. So acetic acid, let's go through. So we have 4 coming from that carbon. We have hydrogen, which is 1, but we have 3 of them. And then carbon again, which is 4. We have oxygen, which is 6, but we have 2 of them. And then hydrogen, which is 1, for a total of 24 valence electrons. And then SF6, sulfur, has a valence electrons. It's right underneath oxygen, so it's also going to have the same number, which is 6. Fluorine is 7, but there's 6 of them, so we're going to have a total of 48 valence electrons. So this is the most that we're going to do with covalent bonds right now. We're going to come back in a few days and we're going to do Lewis structures, but that's something completely different from this. So, all right.